That's really funny.
I'll try and talk to him.
Okay. Here we go. Everybody find the paper? I want you to cross out where it says Gaussian elimination and make that Gauss-Jordan reduction. Gauss-Jordan reduction. We did not even do Gaussian elimination, so we're going to change that to Gauss-Jordan reduction. Notice that it's a calculator problem. The first two are calculator problems. So if we're using Gauss-Jordan reduction, gang, how do we start? We're going to put a matrix into our calculator, right? One matrix. And the matrix that's going in is 1, 2, 3, 4, 2, -1, -4, 1, and 1, -3, -7, -3. Would you agree with that? So let's put it in. That would be everybody, Logan Spawn.
I have a calculator.
Oh,
Should I get one?
I guess you'll have to rent one then, because we're having, everybody's gonna put this in, because we're gonna be prepared. Yeah. Okay, you guys, this is absolutely outrageous. Everybody needs to have a calculator with them every day.
Well, where are we at? This is red.
Anybody want Lily's paper there? So we didn't know what it says.
Yeah.
Hey, where?
If you bring it to me. Thank you.
I know, sure works.
Wait, what am I What did Tom say? Yeah, why do you love points?
Oh my gosh, never seen something with papers. I think I paid exact change.
I mean, if I kept on my change, I'd probably have like 100.
So I do that.
I mean, like in the car, but I don't just hear you.
Okay, so Logan,
I was like, dude, cash that in.
you guys need to pay for these calculators tomorrow. We're not gonna be messing with this for weeks. Time is running out.
This is for not weeks, because we only got
I know, that's what I mean.
I think mine's dead. This is boring.
Everybody has your calculator.
Mine's
Yeah,
dead.
this mine's dead, to be honest.
Okay, it might be. I'll just give you the.
Go.
Yeah, you got screwed.
It may need new batteries. Does it need new batteries?
It's just not doing anything.
Tell me about the founding.
I have no.
And then you go.
We're like the second to last.
That, and then you go.
Thousands of dollars.
Seriously?
And I buy new jumpers. Take fancy vacations.
Dancing is.
I think she's being
Your
serious.
battery is low.
Yeah, because
Well, if it says low, it'll still work
Alright.
for the period.
Second
All right, does everybody now have a working calculator?
I mean, what, like?
Oh, you got it.
Enter this. Enter.
Did I give you change to them?
$15 a day. How many school do you have?
All right, now, everybody's got a calculator.
$3,000. The numbers I crunched were not right.
Harry, why did you give me that phone?
No, I feel like that is right.
3,000.
We don't use calculators every day. Huh? We use calculators every day.
But it's not, it's probably more than $3 every day.
But she has more than one class.
No, I said $3 per class.
Oh,
5 classes a
well,
day.
that would be absolutely ridiculous.
no.
Let's go with the strong 2,000.
1,000.
I just made more.
I was like, we went down.
Oh, wow.
Okay. Do you have it in? What came out? What do?
1
You get it in, and then you have to do what?
The R thing.
You have to RREF,
Got an
and then a new matrix comes out. What came out?
1, 0,
Wait, 1, 0, -1.
We got 2.
Zero.
RREF or REF?
RREF.
Math.
That's what I did.
Go to like the matrix thing.
1, 2.
Second matrix.
1.4.
Then you go all the way down to
0, 0, 0, 0.
Okay.
Not what I got.
All right.
Oh, you go to math. That's where it's math.
That's right.
Did anybody confirm that?
Yeah.
I got it.
Okay. Now, this is a little weird. This is a little weird. Ideally, what comes out is something that looks like this. Because when this comes out, we know our answer is x equals 1, y equals 4, z equals 3. When this happens, remember what we have to do? That bottom row literally says 0z equals 0. No z's equals 0. What does that mean z can be?
Anything above.
Anything. And we write that by saying z is z. Z can be anything. You get to pick it. Now, what about y? Well, what does this equation say? In your new matrix, that equation says what? 1y plus 2z equals 1.4, which means y equals 1.4 minus 2z. So remember, you got to pick a z, right? You can make z anything you want. So if you let z equal 6, okay, then you will be able to get a y value, right? All right, what's the top row of that matrix say? X minus z equals 1.2. So x equals 1.2 plus z. Now again, you can't be any more specific than that unless you pick a z value, right? And then you can come up with specific solutions. But everybody's would be different, depending on the z they picked. Okay, is that okay with everybody? All right, now the next problem says we're going to use our calculator still, and you get to solve using the method of your choice. So, could you do this again? Yes, and that would be perfectly acceptable. But just so we get some practice, the other required method, the other method you have to know how to do, is the inverse method. So let's do this one with the inverse method. Just so we have some practice. Okay. So who remembers the strategy? We're still using our calculator.
Are we doing the same problem or number
No,
two?
we're doing number 2. We set up a matrix of just the coefficients. So 1, 1, 1, 2, 1, negative 1, 3, 2, 3. All right, what else do we do? That's a matrix of just the coefficients.
Can you make another matrix?
We make another matrix, have to call it something different, I'll call it B. And that would be the matrix 6, 1, 16.
You said that.
And then how do I get the actual answer? Well, they got to go in, and then I press A inverse times B. And that should come out the answer. So let's practice that. Make sure we can do that. What'd you come up with? 1, 2, 3. Did everybody else match 1, 2, 3?
I'll come back on that.
And we write our answer like this right here. When we
Yeah.
get an answer, a specific answer like that, we write it as an ordered pair or something like that.
How do you find do you do the inverse for A again?
Huh?
How do you do the inverse for A again?
You put A in, so you do second matrix.
And you just put the mate. Okay, gotcha. Yeah,
Now, listen, you all have to be able to do both of these kinds of problems, the inverse method and Gauss-Jordan reduction. You have to be able to do those on the calculator. So if you still are, a little iffy, practice that a couple more times. Okay? Get that down. Now, the rest of this is no calculator. Although we can check it with our calculator, that might be good. All right, number 3A. Do we know how to add A plus 2B? What do we do first? 2B. And remember, 2B means take 2 times everything in B. Are you agreed with that? So our answer, we can add these because they're the same size. So -1, 9, 14, 17, if I added right. We good? What does B mean, problem B?
Inverse.
Find the inverse of B. Now, you could do this on your calculator. I know you could. But we got to do it by hand also. So how do we find the inverse of B?
Top left to bottom.
Well, we're going to do some rearranging in the matrix, right? So we'll put 7 here and -1 here. Is everybody following along? And then what do we do with the 6 and the 5s? Leave them where they are, but make them both negative. There will be some kids who put that in the answer blank. And I will have to go,
I like it.
Wrong.
What does that mean?
that's, what are we missing?
Determinant.
You have to multiply it by 1 over the determinant. You have to multiply it by 1 over the determinant. And what would be the determinant of matrix B? What?
-7 minus 30. So that is
-37. So the answer, what should be in the answer blank, is -7/37, 5/37, 6/37, 1/37. That's what needs to be in the answer blank. That is the inverse. Remember, finding an inverse is a 2-step process. Everybody's good about building that new matrix by rearranging and stuff, but you gotta remember to multiply by 1 over the determinant. All right, C inverse. This is problem C. Can't do it, right, Maria? You can't do it because it's not square. And if it's not square, it doesn't have a determinant. And if you can't do this part, you can't build the inverse. By the way, did your candidate win the primary? I heard that on the radio and I thought of you. Good job. Okay, D.
The mayor run for candidate.
Nice work.
Woo. Grassroots support.
Yes.
Unseated the incumbent mayor. Okay, I don't know him or anything about it. Determinant of A. What's the value of the determinant? 5. 3 minus -2. E.
Wait.
Nope, we're on problem E. We're moving on. Problem E. What's the determinant of C? You can't do it. You can't do it. We just talked about that. In order to find a determinant, you have to be square. F. Determinant of D. How do we do this? We're going to copy the first 2 columns. Right? Here we go. What do we get here?
you get a 2. You get an 8. You get a 0.
So we get 10. The total is 10.
2.
Now we're going this way.
3, 0, A4.
total is -1. What do I do with those two numbers? Subtract. So the
11,
answer is
11.
11. G, A times B. Can we even multiply A times B?
The math enthusiasm.
Multiply these?
Yeah.
Yes, because what are the dimensions here?
2, 2.
2 by 2, 2 by 2, and the rule is these have to match.
Yeah.
So our answer is going to be another 2 by 2, 2 rows, 2 columns. To fill this position, this is in the first row, first column. So we're gonna multiply the numbers in the first row times the numbers in the first column. We take the first times the first, the second times the second, and add them up. So first times first, second times second, what does that give me when I add them up?
-7.
-7. Now, it doesn't matter what order you go in. If you move over here, this is the first row, second column. So again, first times first, second times second, add them up.
-2.
Now we're in the second row, first column. So that would be 16, first times first, second times second. And then first times first, second times second, that would be 31. There's the product. Now, would you do H on your own? C times D. C times D, another multiplication. C times D. Remember, before you get started, you need to check to make sure you can do it. I think you can do this. What do you think?
I think so too.
I have no doubts.
It's a little bigger. We got the first row times the first column. You're going to have to take first times first, second times second, third times third, and add them up. Please don't just stare blankly at my work. Oh, Sal. Sure you can do it. How does mine look? Anybody? I did it kind of quick, so I may have a mistake there. Everybody matches okay? So matrix multiplication, we're cool? All right, there's one more, CB. C times B.
I
Can't do it, because C is a 2 by 3, and B is a 2 by 2. Those don't match, so I is impossible. On your test Friday, there will be some questions where you will just say, can't do, or impossible, or no answer. Now J, little bit tricky on J, little notation there that we haven't talked about. I'm just gonna go ahead and write the answer, and then you tell me what that little t means. This is the answer.
Flip the dimensions.
What happened? You interchanged the rows and columns. So matrix C, Harry, what are you doing on your iPad?
Typing an English paper.
Well, I appreciate your honesty, but that's not an appropriate thing to be doing this period.
Okay.
So why don't you turn that on? Thank you.
Yeah,
I do appreciate your honesty, though.
I thought you were gonna die.
Okay, C, the dimensions of C
That was great.
are 2 by 3, right?
Not the response I was
C is a 2 by 3 matrix. The little t stands for transpose. Transpose. And what it means to transpose a matrix is simply to interchange its rows and columns. So what was the first row of matrix C becomes the first column of the transpose. So row 1 becomes column 1, and so on. That's what it means to be the transpose. Now, by the way, sometimes that's with a capital T. So your book uses a small t, some books use capital T's. You're thinking, okay, that's great, Mrs. Ford, something else for me to memorize, but what is the point of it? If we were doing like a real study of matrices, there are things where the transpose is a part of it. For example, if we were finding the inverse of a 3 by 3 by hand, now we aren't, we're doing it totally on the calculator, but if we were doing the inverse of this matrix, part of that work would involve transposing. So it's just something that's done, it's a matrix operation, just like adding and subtracting, we transpose. So everybody clear on what transpose means? Take row 1 and make it column 1. Take row 2, make it column 2, and so on. All right, and finally, K, B minus A. Is that possible? It is possible because they have the same dimensions. So entry by entry, this would be a -2, -1 minus 1. 5 minus -1, 6 minus 2, and 7 minus 4. Okay? All right, number 4, solve using the inverse method. This is not a calculator problem. We could do it on our calculator, we already practiced one, but this one we're going to do by hand.
I'm like 27% sure.
Now, listen, when we did it on our calculator, we actually got the answer by doing this, right? This is the operation that gave us the answer. Now we're going to do that by hand. So we got to find the inverse of A. What do we mean by A? What is A?
1, 2, 5.
It's the coefficients. So it would be 1, 2, 5, 1. So you got to find the inverse. Well, we just practiced that and talked about it. What's the inverse going to be? I'm going to take these two and switch them. Make these negative.
I'd be lost.
-1/9. So your inverse is -1/9, 2/9, 5/9, -1/9. Everybody still with me? Remember, this is how you solve with the inverse method. Whether you're doing it by hand or with your calculator, this is what you got to do. So that's A inverse. Now, what do I need to do with it? And what do I mean by B? 4, 2. So we're going to take row 1 times column 1. Row 1 times column 1. And we're going to end up with negative, oh, I got 0. Did you?
Yes.
And I got 18/9, so So 2 for that one. So our answer is simply 0, 2. Number 5 is a different system, and we're solving it a different way. Anybody remember how to do that? This is different now. I mean, it's the same idea, same goal. We want to come out with the answer, but we're using Kramer's rule.
So you put them in the two matrices.
So we gotta find, first of all, we gotta find the determinant. What determinant do we start with? 1, -3, 2, 5? And what's the value of that determinant?
-1.
Watch it.
Oh, it's
It's
11.
5 minus -6.
Sorry, I was bored of sitting. I'm so sorry.
She appreciates your honesty, but put that away. Just get that off your desk.
Come on, I'm trying to be nice and get some homework done for you,
I'm
all
so
right?
sorry.
Now, so what do I do with the 11? I'm doing Kramer's rule now. What do I do with the 11? Make it the denominator, right, Mary? Make it the denominator. I'm looking for x and y, just like I was here. And they're going to be fractions, and they're over 11. Now, the numerators will be more determinants. Remember how to do that one? These are the x's and the y's here. So I'll take out the x's and put in 2, 8. And I'll take out the y's and put in 2, 8. Where did the 2, look at your problem. Are you looking at your problem?
Those are the answers.
Oh, okay. Okay, so what's this determinant right here?
34.
34, so we get 34 11s. Hideous answer, but who cares? And this one comes out to be
4.
4 11s. So our answer is 34 11s, comma, 4 11s.
This is the same thing as like elimination or substitution.
Yep, both of these are, it's just a different strategy, but the goal is the same. Where do they cross? All right, number 6. Anybody? Let's see if we can get 6 done before the bell rings. Anybody remember how to do 6?
Vectors.
Yep, we need a couple of vectors.
Oh.
Okay.
Looks like we failed.
All right, so you have to do, all right, 10, cross 10 off, we didn't get that far. So you have to do problems 6, 7, 8, 9.
Cross 10 out completely.
Yep. You have to do problems 6, 7, 8, and 9. Got it? That's your homework. Do it. If you have my calculator, please do that.
He's cheating me back.
You want the charger too?
Yes, here's my calculator. Bring it back.
I still only have a page and a half. 90%. I'm trying to get on
I'm literally gonna go talk to Richard and then I'm gonna pay him half, but.
Only a sentence on it.
Yeah, I'm trying to get on
Appreciate that, man. I was wondering why I should cross off on
Touch
this.
it there.
It has to be.
Well, yeah, but yeah.
I'm not scared.
She texted us all yesterday.